Batteries are fundamental components of our daily lives. They quietly work to keep our digital world running. Right from the tiny cells in our wristwatches to the compact yet powerful batteries in our smartphones, we might not be very conscious but are consistently watchful about them. Without them, many of our daily conveniences would simply vanish. Power banks have made a huge breakthrough in the market, offering wider compatibility, powering many kinds of electronic devices. On the bigger end, batteries have now moved beyond personal gadgets, bringing a revolution in transportation. Electric vehicles with advancement in battery technology represent a major shift towards more sustainable transport, reducing reliance on fossil fuels. Despite these domestic uses, vast battery installations are seen in hospitals and data centers, where reliable power is a matter of life and death. These massive battery banks ensure that critical systems never falter, even during blackouts or emergencies. In industrial settings, batteries provide for continuous functioning beyond the availability of power. Keeping essential operations running smoothly, they safeguard against costly disruptions. This incredible diversity in application, from handheld remote controls, sophisticated laptops, power-hungry mechanical tools, to expensive medical devices, shows just how fundamental battery technology has become. Batteries come in all shapes and sizes, tailored to fit the needs of countless devices. They enable us to work, play, and connect wherever we are unplugged from the walls. However, every battery eventually reaches the end of its useful life. Devices slow down, malfunction, or stop working upon battery drainage or decay, leaving behind fancy shells that need to be replaced. What happens to these power packs when they can no longer hold a charge? Many end up forgotten, or are simply thrown away. Is this the end of their life cycle? How we handle used batteries has a big impact on our environment. We discard billions of batteries each year, creating a significant environmental challenge. Improper disposal can lead to toxic chemicals leaching into soil and water, harming wildlife and people alike. This is the other side of our powered-up world that we must address. As our reliance on batteries grows, so does our responsibility to manage their life cycle wisely and sustainably. The convenience batteries bring is undeniable, but the question of safe and responsible disposal is growing louder. More people are becoming aware of the need to recycle and reduce battery waste. As we move forward, understanding and addressing the full journey of batteries, from creation to disposal, will be key to building a truly sustainable pattern, changing how we live and work. Each battery is a complex package of chemicals and metals, carefully engineered to store and deliver energy. Insides are layered with substances like LED, cadmium, lithium, cobalt, materials that are both valuable and potentially hazardous. Spent batteries are not just rubbish. They represent one of the fastest growing waste streams in our modern world. Although this waste has reduced, not due to mere advancements in recycling, but with emergence of lithium polymer batteries that carry more charge but pose a greater risk. When batteries are discarded improperly, chemicals can leak out, contaminating soil and water, threatening ecosystems. Some batteries retain a small charge even after use, which means they can spark if crushed or punctured. Other kinds of batteries are crucial, which catch fire or even explode if the substances flow across layers or come in contact with water. This is a growing concern in recycling centres and landfills worldwide. Responsible recycling is thus crucial to prevent human injuries from pollution and fires. It is also essential to recover valuable materials. Metals like lithium and cobalt are finite resources, and mining them is both costly and environmentally damaging. Extracting these materials often leads to habitat destruction, water pollution, and significant carbon emissions. By recycling, we create a circular economy, an efficient system where materials are reused and repurposed, reducing the need for new mining and minimizing waste. Instead of the old model of take, make, dispose, we move towards a future where we make, use, reuse, and recycle. This shift is essential for sustainability. For batteries, this means transforming an environmental problem into a sustainable solution, turning waste into new products, and reducing our reliance on raw materials. Achieving this vision requires a collective effort. Governments, industries, and individuals all play a role in making battery recycling a reality. The potential for positive change is enormous, but it demands ongoing innovation, investment, and commitment from all of us. As we look to the future, we must ensure that the technology powering our lives and our planet is truly sustainable, protecting both people and the environment for generations to come. In recent years, some battery manufacturers have turned to using thinner outer shells in their products, aiming to cut costs and reduce emissions during production. At first glance, this might seem like a smart way to make batteries more affordable and environmentally friendly. However, this approach comes with serious risks. Thinner shells make batteries much more vulnerable to physical damage, increasing the chances of leaks, ruptures, or even fires, especially in demanding environments like vehicles or backup power systems. Batteries with reduced casing thickness are less durable and have a shorter lifespan. This means they need to be replaced more often, which actually leads to more waste and higher long-term costs for consumers and businesses alike. The safety hazards are significant. A compromised shell can expose toxic chemicals or heavy metals, posing health risks to people and increasing the likelihood of environmental contamination if the battery is damaged or improperly disposed of. While the intention may be to lower emissions and save resources, the reality is that these shortcuts undermine the reliability and safety of batteries and can actually increase the environmental impact over time. Instead of cutting corners, the industry should focus on robust design and responsible manufacturing, ensuring batteries are both safe and long-lasting. Stronger, well-designed battery shells protect users, reduce the risk of hazardous leaks, and make recycling processes safer and more efficient. Choosing durability over minimal material use is essential for a sustainable battery market, one that values safety, longevity, and environmental responsibility. Cutting costs by thinning battery shells may seem appealing, but it ultimately leads to more problems than it solves, turning a potential solution into a new source of risk and waste. As we look to the future of battery technology, it's clear that safety and sustainability must come first. Short-term savings should never outweigh the long-term well-being of people and the planet. The lesson is simple. Robust, thoughtfully designed batteries are the only way forward, ensuring that our energy solutions are safe, reliable, and truly sustainable for generations to come. Second life batteries are a modern take on reusing and recycling. Large lithium-ion batteries can be repurposed for less demanding roles. When a battery's capacity drops, it can still hold significant energy. Instead of recycling, these batteries can be used in stationary applications. This extends their lifespan and reduces the need for new batteries. It has environmental and economic benefits, conserving raw materials and lowering carbon footprints. Second life applications transform waste into valuable assets. This approach aligns with the principles of the circular economy. It's a win-win, making the most of existing resources. By repurposing batteries, we build a more sustainable energy ecosystem. Retired electric car batteries have exciting new applications. They can be used for stationary energy storage in homes and businesses. Connected to solar panels, they store excess energy for later use. This reduces reliance on the grid and lowers electricity bills. Second life batteries can also support electric vehicle charging infrastructure. They act as buffers, reducing peak loads on the grid. Real-world examples show the viability of this technology. Car manufacturers are partnering with energy companies to redeploy old batteries. This approach builds a sustainable energy ecosystem. It's a practical way to power our future with second life batteries. Repurposing batteries is a technical process requiring careful assessment. Batteries undergo health checks to determine their suitability for a second life. They can be reconfigured into new systems using the healthiest modules. A new battery management system ensures safe and efficient operation. Design for disassembly can make future repurposing easier and more economical. This forward-thinking approach is essential for scalability and sustainability. It reduces costs and complexity, making second-life batteries more viable. The process requires innovation and collaboration across industries. By planning for the entire life cycle, we can maximize battery value. This strategy supports a sustainable future for battery technology. The push for better battery recycling and second-life solutions is urgent. The electric vehicle revolution is creating a future wave of battery waste. Robust systems are needed to handle millions of tons of spent batteries. Mining for new materials is environmentally and socially costly. A strong second-life market can ease the pressure on resources. Research and development are critical for improving battery assessment and recycling. Automated disassembly and new recycling processes can enhance efficiency. Governments must support this transition with policies and investment. Initiatives like battery passports can streamline the recycling process. Innovation and collaboration are key to turning this challenge into success. The journey of a battery from waste to a second life is a shift in thinking. It's about taking responsibility for products from cradle to grave and back. Innovation must be guided by responsibility and safety. Safety standards are crucial for everyone involved in the process. Research into safer chemistries and better management systems is vital. The goal is a net positive impact, reducing environmental footprints. The circular economy aims to work in harmony with nature. The second life battery story is one of hope and responsibility. It shows we can power our future without leaving a legacy of waste. By investing in sustainable innovation, we ensure a cleaner world for all.